Let's look at what happens when we try to reduce alkynes. So let's just put our groups on our alkyne. If you react an alkyne with hydrogen and palladium on carbon, what happens is you can't control this reaction. You will add one equivalent of hydrogen to the alkyne to make the alkene, and that is a syn addition. I'm not showing this very clearly, but that would be a syn addition. And then, as soon as that formed, the alkene actually reacts faster than the alkyne. So as soon as the alkene forms, the alkene reacts as well. And you end up adding two equivalents of hydrogen. You simply can't control this. You can try to use less and less hydrogen, but it really doesn't work. So how can you do this with some control? Well, as it turns out, we can take our alkyne and we can treat this with hydrogen and a different catalyst. Instead of palladium on carbon, it's a nickel boride catalyst. And this reaction actually stops very nicely at the alkene, and you get the cis-alkene as the product. And so this is also a syn addition. There's another reagent that allows you to do this. Alternatively, and you'll see this in older textbooks, hydrogen and palladium on not carbon but barium sulfate, and this is called the Lindlar catalyst. And the Lindlar catalyst will also give you the cis-alkene. Honestly, I don't think it works all that well, but it's a classic reaction. Everybody knows Lindlar's catalyst, and using hydrogen and palladium with Lindlar's catalyst will give you the cis-alkene. Okay, as it turns out, there is another reaction that you can perform that'll allow you to get the trans-alkene. And we're not going to go through this mechanism, but if you treat an alkyne with sodium metal, that's sodium 0, in ammonia, this actually will undergo a series of electron transfers and protonations that will give you predominantly the trans-alkene. Now, this is a completely wild and crazy mechanism. It's a free radical reaction. We're not going to learn it. But this is another classic reaction. So sometimes you have an alkyne and you want to get the trans-alkene. How do you do that? You treat it with sodium and ammonia instead. This is a classic combination of reagents. It makes something called the sea of electrons. The sea of electrons is this deep blue color. It is visually a really cool reaction and cool process. And that allows you to get the trans-alkene. So starting from alkynes, we can either form alkanes, we can form alkenes, and we can select, do we want the cis or the trans-alkene? And based on the reaction conditions and reagents, we can control for that.